So, welcome to part 2 of the 2110 Fest. I think the momentum behind 2110 is fairly obvious these days. We're seeing a lot of live production moving towards 2110. There's plenty of it in operational right now. We've heard about some of it already. And there's plenty more, I think. And what we're going to see as we move forwards is, I think, projects with more ambition, more scope, more scale. So our 3 speakers this afternoon are going to talk to us about understanding some of the challenges that they have already met or that we're going to meet as we head towards that ambition, that scale, and the more adventurous projects that we can achieve with the benefits of IP and 2110, okay? So first up we have Andy Rayner from Nevion. He's going to help us to understand how, where the challenges may be as we move 2110 from the local area network, from the studio, out towards wider area networks, connecting more stuff together. Okay, so let me just give you a little bit of history. He's very recently been elevated by SMPTE to a Fellow of the Society. Well done, Andy, hence his very, very slight lateness, but we'll forgive him on that one. He's the Chief Technologist at Nevion. He provides a company-wide technical strategy and direction. He's on the VSF Board of Directors, and he's part of the AIMS technical working groups. He's an active participant in many standards forums, including SMPTE. So please welcome Andy to the stage as he talks to us about beyond the LAN, essentially.
Good afternoon. Sorry for holding proceedings up a few minutes then, but it's a great pleasure to have spent the last hour upstairs with the very distinguished other fellows. So, looking forward to sharing with you for the next few minutes wide area facilities interconnect with ST2110. So, a couple of bits of explanation as to what I'm talking about first, and we'll then get into it. So, the working group that's part of VSF that I've been chairing for just about 12 months now is all about how we actually interoperably interconnect facilities with 2110 whilst affording some of the protections and aggregations that we may want to do when we actually traverse wide area networks for 2110 signals. So what does that actually mean in terms of what we're trying to achieve? I've got 3 typical user case scenarios that I think it's worth considering as we look at this. The first is the typical, what you may call a REMI or a home production, where you've maybe got a truck or a facility and you're trying to actually backhaul all of the individual media feeds, the individual video and audio flows to do it at home production. The second scenario is when you've actually got, as a company, more than one campus and you're looking to do a secure, controlled and flexible interconnect between IP production facilities within your company. And the third one, which obviously has slightly different ramifications, is when you're actually looking to interconnect between facilities that actually have different ownership. So you're actually looking to hand off between one entity and another with that interconnect as well. So there's a load of other stuff that may come into play there. And 2 layers of focus we want to look at as we do this. One is what I call the media essence flow, so the data plane, the interconnect of the actual video, audio, ancillary data, and other data flows. And the second, and equally important, and arguably even more complex, is the registration, discovery, and control. How we actually, the control plane basically for that. And as an aside, while I'm standing here, I think it's worth kind of questioning as to why we in SMPTE thought it was so important to actually standardize within SMPTE the actual data plane, but we haven't actually done the control plane, given it the same elevation of status. I'll leave you to ponder on that while I carry on. Just to emphasize, this could be a truck. When I actually talk about between facilities, it could be a campus to campus, it could be campus to truck, it could even be truck to truck. It could be any scenario when you're actually looking to interconnect 2 facilities. I'm not going to dwell on this. This is kind of a little bit of a menu, but this is some of the things we've been considering as we actually move through the studies and the discussions that we've been having on what's important as we transit over wide area for distributed and remote production. So one or two of you will have seen me use this slide a few times before to actually talk about the edge of the facility, but I think it's useful going back to it because it does actually emphasize a few important elements. First of all, on the green side, which is our land side, there's some stuff that hopefully, especially you've been listening to some of the talks previously, some things that hopefully in order and will be well defined within your facility. If you were listening to Mr. Kernan this morning, you would know, hopefully you would have a pristine PTP timing environment and a secure one at that within your facility. You would also have hopefully implemented a mature NMOS control and discovery and registration system. You would have an IP addressing scheme which is actually well thought out and actually addresses all your needs. You've probably, if you're running 2110, got essence flows, and you're doing probably 2022-7 to do the RTP protection. What we see on the far side is all of the things that you may not be true once you go off your facility in terms of alternative timing domains. You've actually got a lot of stuff you want to be concerned about in terms of the control layer. You've probably got to address translate both the data plane and the associated elements of the control plane when you go off campus. You may even be going to something like 2022-6 rather than staying essence-based as you go off net. And you may well have other kinds of protection like FEC that you're applying in the wide area that you wouldn't be using within your facility. So those are a few of the things to start thinking about. So what we've been trying to consider very specifically is this interoperability point on the right here. So we're not trying to actually define everything that possibly the gateway function needs to do, although some of those things are implicit by what we're actually defining, what we're talking about. But it's that interoperability point on the, if you like, the WAN side of the facility gateways is the kind of stuff we've been thinking about within the group. And I call it here a DMZ because I think it's important to consider that, you know, from both of the facilities, and again, this is regardless of whether they're a full campus or a truck or anywhere in between, there's actually security both at the control and data plane that we need to be aware of at the ingress and egress of both of those elements as we traverse the wide area network. So starting with the easy bits, a few easy bits. First of all, it's a no-brainer to say that we're going to use 2022-7 to protect the data plane flows. That's already been defined in the rewrite that we did of 2022-7 last year to apply it to 2110 essences. So that's kind of a given, and I would anticipate everyone will be using that in the wide area networking, in the wide area network as well as in the local area network on campus. Secondly, we visited some of the FEC that's already been defined in the 2022 suite and looked at the -5 and said, actually apply a constrained version. And when I say constrained, that's constrained by the length and depth because we want to minimize latency. We'll apply a constrained version of that to our flows if we deem it necessary. And just to actually emphasize, what we're talking about here is a toolkit of best practice that you have the option to use. Moving on, slightly more complex one is trunking. There are several reasons why we may want to aggregate multiple essences together as they traverse a wide area network. First of all, you may not want to actually leave the routing of all of the individual essence flows that you are looking to take from point A to point B, a wide area network, up to the service provider. You may feel much more comfortable wrapping them together and sub-aggregating them so the service provider can't actually take your different essences on different routes through their big network and therefore give different latencies and different performance to the different, for the different elements you're carrying. In addition, there are some challenges. You'll notice, if I just go back to the FEC thing here, you'll notice that that FEC is based on a number of packets. If we look at our number of essences here from our 2110 suite, our -20 flow at the top could be, as an HD essence, the order of 1 gigabit per second. It could be as a UHD essence more like 10 gigabits per second. If we look down at dash 30, if we're talking about mono audios, they may be sub 1 megabit per second, and our paltry ancillary data flow may be the order of 100 kilobits per second or less. So we've got many octaves of bandwidth there, and correspondingly, if we apply FEC to individual essences, we'll introduce very skewed delays and differential latencies on the different flows. So aggregating them together as one big clump will actually help to actually make sure that they're all subject to the same routing delays and the same protection delays. We did some work looking at this, and the third one down is what we've kind of come up with as going to be in our draft recommendation, which is basically looking at the generic GRE encapsulation, but adding an RTP header on top of that. And the reason we've done that is simply because we can then apply our existing toolkit of 2022-7, 2022-5 to the trunk as well as to the individual essences. So I won't dwell on that anymore. We'll just point out at the bottom, though, that we actually have the ability to carry not only IP flows, but we can carry Ethernet and even other data types using the GRE header. So there's some flexibility there as well. Just want to, as a comment, to say, again, because this is going to be a toolkit of recommendations that we're coming up with, you may or may not want to apply different protection mechanisms at different layers, and that's entirely up to you as an implementer. I'm just put up here to show that you may choose to do the 2022-7 RTP merge protection either at the trunk layer or at the essence layer, and it will be entirely up to you as to which of those you choose to do. I'm not going to go into the details here. I left this more in because of the handouts and stuff, rather than because we're not going to dive into the individual bytes that are used here. Also want to say one of the user requests that we had when we started to look at the requirements for carrying 2110 over wide area networking is the requirement to securely take other data stuff as well. Now, when I say other data stuff, this may be other UDP or RTP streams, or may even be other TCP data, but there was a strong view from the service provider industry, especially in the US, that there was a requirement to actually protect all data as well as the media essence flows in a similar way. Now, on to timing. You will obviously, when we get to the point of going off network, there is definitely a requirement that we actually need to align or at least know about the relative timing of the individual essences. So what you'll see here is my top flow is a video essence flow through a very minimal production environment, and at the bottom I've got an audio flow through a minimal production environment. What I'm trying to point out here is they're both subject to different degrees of latency due to the different processing. And once we go off campus into our wide area network to hand off to someone else, there is two requirements that we've come up with. The first requirement is, ideally, we actually have reconciled the relative timing of those essences. So the actual timing of the video and audio is in alignment as we egress the facility to go wide area network. As an alternative to that, because one or two people have pointed out we may not want to introduce unnecessary padding and start padding out the timing for certain flows as they egress the facility. As a bare minimum, the RTP timestamps on the relative media essences need to actually be describing the relative time offsets between the flows. So that's kind of the bare minimum. So the RTP timestamps have to honor those relative things. And I'm going to say that a little bit about that in just a minute. But talking of time, no, I'm going to come on to that in a minute. I'm going to come back to time in a minute. Just want to say the 2110 toolkit is expanding. Now, some of these haven't quite made it through to reality yet, but the toolkit is building on a month-by-month basis, almost. One thing I want to draw attention to we've actually used a lot in the last 3 months, and although I was a little bit hesitant about it as a purist when it was introduced as a concept a few months ago, and that's the -22, which is the compressed video essence flow. Because as we go wide area networking, there is actually quite a significant requirement, especially if you're long hauling, to consider doing some compression, especially of the video essence flows. So actually having the Dash 22 as part of this family is actually been very, very useful within the wide area networking applications of 2110. Just want to talk to you briefly about my family, which is expanding. I've become very old in recent times, and that's been accentuated by the fact that I'm now a grandfather, and my granddaughter celebrated her first birthday last weekend. So I calculated at 25 frames per second, which is the only frame rate we should ever worry about, I reckon she's had, from her epoch, 790 million frames. I was obviously startled to see that I've actually had 41 billion frames since my epoch, which is more than the epoch of PTP itself, which is quite scary. Anyway, moving on from that little aside of mine, back to the time. One thing that I'm very pleased we've actually managed to revisit a little bit in the review of the one-year review of Dash 10 of the 2110 suite is some of the recommendations about timestamping. Many of you will have realized once we actually started the work on 2110, the timestamp was actually timestamping the origination of the media itself. So the video frame or the audio sample that's capturing that audio, and that time is captured. As we actually move through a workflow, then typically that actually gets lost, because if you saw from that diagram, I'm just going to shuffle forward a couple here just to show you that again. A lot of equipment that's currently being used actually rewrites timestamps and pays no reference to the origination timestamp, which means actually a golden opportunity is lost because we're not able to track time through the process. Now, these two slides, sorry, they were slightly out of order there. I think actually this is probably the reason why it's happened like this. We weren't possibly tight enough in the original definition of Dash 10. I think probably quite a lot of initial IP equipment that was introduced to the market had kind of IP interfaces on another piece of native digital but not IP equipment. Therefore, timing was difficult to be reconciled and carried natively through the equipment. Whereas now, this is the kind of architecture that we're starting to see in products where the actual time and the propagation time is compensated for. So we're actually able to maintain origination time as we actually move through pieces of equipment in the production chain, which consequently means we do actually have then the potential to reconcile timing of different media essences automatically, which in application to traversing the WAN means we can easily meet that requirement of aligning the relative essences or ensuring that the RTP timestamps define the relative offsets as we egress a facility and move to another one. I mentioned briefly Dash 22. Compression is a very viable and necessary thing in many wide area backhauls. In the UK, that the cost of bandwidth seems to be, relatively speaking, low, and we've actually seen some significant examples of the use of uncompressed transport in the wide area networking, certainly for HD, and I've even seen some examples in recent times of the intention to do that for UHD as well. So that's, whereas certainly if we're going internationally, then the requirement to do some kind of compression is very important. And anecdotally, you heard a talk yesterday on JPEG XS. That's something we've actually started to deploy in anger in the last couple of months, and a real solution. And the great thing about that is it only has a very, very, very low latency. In fact, once you're backhauling connectivity internationally, that compression is completely negligible compared with the fiber transit delay. So I talked about the data plane and how easy that bit was, relatively speaking. The control plane gets a little bit more complex. So what we're looking at here is the key user requirement we had coming in from the user community was, my campus needs to be secure. And the last thing I want is to federate my control system in a way that allows somebody else in another facility to completely screw up what I'm doing. So security and segregation was a key element. So we've worked on this principle of a proxy function here. And the idea is having a proxy gateway on the edge, if you like, on that edge of each campus, that actually allows the registration information and the control information to be proxied securely over the WAN and to the other end. Now, many of you will be aware of the NMOS toolkit that many of us are using now in anger. I think it's come of age in 2019. And I just want to do 2 quick 1-minute examples about how that actually is looking in the proposal that we've come up with. So I won't dig into lots of detail on this. I'm more than happy to talk to you about it afterwards. But the concept in this first slide, this is the registration. So this is the first part of the chain when a device actually says they're available and a feed is available to be used. And specifically here, Facility 1 is making a resource available to Facility 2. That might be a camera, a microphone, or something else, but it's a source. And the very specific thing that we need to do is to have a whitelist, a dynamic whitelist per facility of the resources that are going to be shared, because you actually can say, this afternoon between 3 and 5 o'clock, I'm going to make these 8 cameras available to this other facility to use remotely, and these microphones, these other resources as well. So what we're showing here is 2 layers of proxying, if you like, which is part of our proposal, to make those resources available to the other facility. And I will just say, I will not dwell on this slide other than to say the authentication is one of the little bits that we're still working through at the moment, how we actually use the existing authentication stuff that's been worked on for within the facility, how we actually apply that in the wide area network. So that's stuff that's work in progress. But the other example is going the other way. This is the control element. So we talked about how the registration could work just now. Now we're actually looking at the reverse direction, where in Facility 2, on the right-hand side, the user or the controller is saying, I actually want to make a connection to that source, which is in Facility 1. So there is effectively 2 layers of proxying of those sources through the gateways. And we think this actually will give us a very effective and secure way of actually brokering resources, having that kind of plug-and-play ability, but with security and some constraints in it between facilities. Security is obviously important at both the data plane layer and the control layer, and I won't say any more about that now, but it's not to be underestimated, and this is a key focus. We won't dwell on timing domains, just to say that once you go off campus, you do have to be able to protect against the concept or the risk that the timing domains may not be reconcilable. The premise probably will be that everything's GPS locked, so all your campuses or trucks are GPS locked, but there are situations when they're not, so we have to allow for that in the definitions. So, in brief summary, because I think I've almost used my time up, we've actually had a lot of good work looking and exploring the user requirements, the use cases, and how we actually think could be best, what we think could be best practice for brokering the interconnection, both of the data plane, the actual flows, but also, very importantly, the control plane and how we can make that secure and interoperable in a multi-vendor environment moving forward, as we want to do more and more federation to some degree or other of facilities and actually leverage the full benefit that IP and distributed IP production can give us. So it only remains for me to say, as I always do, if you're ever in the UK and want to come for a really nice cup of tea, then do give me a shout. I'd love to hook up with you. My contact details are here. Thank you very much.
Andy, thank you very much for recovering some time. That's awesome. That was plenty of good stuff in there. Do we have any questions? We have time for questions? Well, I have a question. So you mentioned FEC. Do you have a feeling for the latency you're talking about there?
So the great thing about FEC is that it's proportional to the data rate. So if you're applying FEC to those a video pipe, a video flow, or a video plus other flows aggregated, then it's going to be a fraction of a millisecond at the data rates we're talking about. So it will be negligible. The reason I raised it as a specific issue there from a latency perspective is, if you're talking about 100 kilobits per second rather than 10 gigabits per second, then you could typically end up with incurring 100 milliseconds of delay to one packet where you're actually introducing virtually nothing to another one.
Okay, so I mean that sounds perfect for remote production. You're adding almost nothing, right? Perfect. I have another question, because I quite like your trunking, although I'm going to have a bit of a grumble about the naming. It's going to confuse people. It's obviously got many benefits, this idea of wrapping stuff together. You mentioned the benefits. There's got to be some downsides, right? What about, do you see a problem with having similar content that you need to distribute to multiple places in a kind of a, not multicast, but like a multicast mode, where you're obviously now generating multiple sets of roughly the same thing?
Yes. Okay. So the big unicast versus multicast question. So first of all, to say we're not suggesting that any of these elements are mandated. They're just a toolkit which you can choose to use as part of the interconnect. I think typically most use cases we see are point-to-point in the use of certain facilities. So it may well be a large campus may actually be federating different resources with 2 or 3 locations for different productions, but per resource, each resource is likely to be only federated to one destination at a time, which is why I was saying the whole point about dynamic whitelisting, because we see that this resource sharing and this resource brokering very much needs to be a dynamic thing.
Okay, thank you. We got a question. Could you state your name and affiliation?
Zaydan Alawi from Cine Media. Question regarding the guys from RIST Farm. They working on a solution for trunking for IB trade. Is there any coordination between your work and the guys from RIST?
So I would like to say yes. I mean, several of us are aware of what's happening in the different activity groups. They've actually chosen to use the GRE over UDP rather than GRE over RTP because they had less requirements to use their existing toolkit of protection mechanisms at the trunking layer than we did within our facility. So the common elements are it's both a GRE wrap. They're just doing a UDP header. We're adding the RTP element to the final header to allow us to apply FEC and 2022-7 as is without having to redefine those standards.
Thank you very much.